I took the shunt bars off. I had to do some fix up to the three-phase transformer, central portion of the bit transformer. And this top bar, this actually, you can take this off. You know, you can just take this off. And this bottom bar and here and here and here, the three legs, they're all solid, but this one comes off. And so it made it pretty easy to wind, but I was noticing that I could take this and move it like this, kind of rock it like this. And there's on the top of each leg, looked like maybe this had been overheated at some point. There was a ridge in the middle where the laminates had kind of stuck up. And you could put a razor blade on it and rock the razor blade pretty good. And you could rock this too. And I was noticing when I was testing a lot that you could grab this and move it, and it would always kind of make a growly sound. So I filed it for about an hour till I got it absolutely flat on all the tops of these. And I've always had this problem where this coil didn't make as much as this coil, and quite dramatically too. And at one point I got it so it was pretty close, but it's always not making as much. So I took this coil apart and I rewound it, and now I have this one right hand rule looking like that. That's my left hand. Right hand rule here, left hand rule here. So there, somebody said that you should do that. So as long as I was rewinding it, I thought I'd do it like that. And now I'm running on 120 volts right now, and it's just quiet, very nice and quiet, no heat really in the primary. And you see I got these really tightened in there good, this bar going across, this laminate bar. And so I also put a little bit of super glue around the edges when I put this on to make sure it stays kind of solid right where it is. And so this was a big improvement. Now I have the secondaries put out the same at 120 volt input. They both put out about 59 volts each. And so when you add them up, it comes to almost what's coming in. This is without a load, just checking. So right now I have a load of a very hot, look, it burned it, 378 ohm resistor right there. And I have that, this one in series with this one. And I don't have any caps or anything anywhere, just 120 volts into it. And look what I get now. Output is 104.3. It was 104.3 a little while ago, but now it's up a little bit. But let's go conservative. If you times those, if you square 104.3 and divide by 378 of the resistor, you get 28.7 watts output. Now, what goes in has got a 56-degree phase shift, and it happens to be, the cosine of 56 is 0.559, so I'm going to say 56 for the cosine. sorry, 0.56, duh. So they aren't the same, but there's a decimal point, so it's funny, the same number, but whatever. So look at this, 120 volts AC, we know that's 120 because it's just right from the grid, and I measured it, it's 120. And it's 35 amps, 0.35 amps, 350 milliamps, times the power factor of the cosine, which is 0.56, is 23.5 watts input, and we have 28 watts output. So I'd say this is a very efficient transformer on its own. Maybe the type of windings I put there that nobody else does, the 16 parallel lengths of 23 feet wire, 25 gauge, so it's series 80 times 16. And each of these is about 12 ohms each. Each of these coils are the same. I don't know, but that's what the numbers say. And in case you don't believe me, you have to believe me about the voltage because it's coming from the grid. And with a 0.02 square division on the amperage, where I'm measuring amps, you know, with a 0.1 shunt. And here's the amps, the tall one, and it's 25. Maybe a little less, but I'll say 25. 25 spaces is what I'm talking about. 5 square divisions, 5 spaces each. So it's 25 for the amps. And look at the phase shift. I am saying 1.4, it's maybe a little bit less than 1.5 spaces. So I'm saying 1.4 spaces, and if you look at the cycle, 360 degree cycle, if you count that, it's 9 spaces. So 360, 9 spaces per 360 degrees, and that comes to be 40 degrees per space, because 360 divided by 9 is 40. And then I figure there's 1.4 spaces of the phase shift, so that becomes to 56 degrees phase angle, which is equivalent to 0.559 cosine, so I just said 0.56. So, isn't that interesting? Alone, it's a little bit over unity. I bet you I could get better if I put a 11 UF cap in series or so. But right now, interesting how it is. Okay, I really fixed this up. I wish I'd taken a video of how much it rocked, but you could take this and move it. It would. There was a ridge there. Really oh, yeah. Okay. Oh. Okay. Gotta hold on.